baby's how we link up. We done did everything they could think of. Greatness is what we on the brink of. I wish that I could have this moment for life, for life, for life. 'Cause in this moment I just feel so alive, alive, alive. I wish that I could have this moment for life.
Alright, here we go. 1.3 measuring angle. So we got a little Nicki Minaj to get us going here. Hopefully you checked out the warning sign. You got to have a protractor to do this. You need it for the practice. You need it for the mastery check. So I know that Mr. Kelly, Ms. Sullivan, and myself all have protractors in our room. You can borrow one. So make sure you have one for this lesson. Rock and roll. Here we go. Talking about angles. So last time we were measuring segments. Today, or on this section, we're going to measure angles. So let's define an angle, get things rolling. An angle is what? It is two rays with a common endpoint. So you've seen angles before. Let's just have the formal definition. So they share the same endpoint. They have a common endpoint. So obviously the picture is going to look something like this. Here's a ray, and here's another ray. They have the same endpoint right there. So we have some more vocabs. This common endpoint is called the vertex. So the vertex is the common endpoint. So a lot of times we'll refer to that. It's that endpoint they have in common. And other parts of the angle we need to know. So we've got vertex. We also need to know the sides. What are the sides? Well, the sides of an angle are just the two rays. So make sure you're good with an angle, vertex of an angle, sides of an angle. So when we have an angle, sometimes we can name it just by its vertex. If we name this point A, we can say, hey, that's angle A. So this little sign here, almost looks like a left-hand sign, is angle A. That's fantastic when it looks just like that. Other times when we draw angles, here's a nice angle, we put a number in there like 1, and we say, hey, that's angle 1. That's my favorite way to do it. Just put a number in there and say angle 1. Other times, though, we need more information. And the safest way, sometimes we have angles like this. And let's say we've got a bunch of points here. So I'm going to do these as, let's do it as math, M, A, T, and H. So maybe we have a picture like this. Can I call it angle A? Is it cool to call it angle A like I did up here? No way, you can't call it angle A because there's two angles here. You've got one here and one here. So now you have to actually be specific. Now I'm referring to angle TAH. And the key is this middle one has to be the vertex. So now I know what you're talking about. This must be the vertex. So I'm referring to, if I put numbers in here, here's a 1 and a 2. Which angle am I referring to? Yeah, I'm referring to angle 2 there, TAH. So it has to go in order. You can call it HAT if you want, HAT. As long as A is that vertex, I know what you're talking about. So this is the way we're usually going to do it. Just make sure you get the vertex in the middle. Very nice. So some other things we got to make sure we're good with on angles here before we get going too far is this. What if there's a little M in front? What does that mean? Well, this actually refers to the measure of the angle. It's almost the same in segments. Remember we had a bar on top and no bar on it? This is actually saying, what is this angle? So instead of saying, inches or centimeters or units, this is in degrees. So in this case, the measure of angle dog is 52 degrees. It's the actual measure. What is this referring to? It's referring to the actual angle. So when you actually don't put an M here, I'm just referring to this angle here. So same thing with a line on top, no line with segments. We're going to measure, this is always in degrees for us in geometry. And then on the bottom here, I kind of snuck it in, equal versus congruent. So the same thing here. I can say the measure of angle A is 70 degrees. I can say this is 70. I can also say the measure of angle BCA, so I'm referring to this as 70, depending on what you want to call it. So what am I saying? I'm saying that the measure of angle A is really equal to the measure of angle BCA. Why is it? Because I'm saying, 70 equals 70. So it's the equal sign's cool, it works. Or we're going to use our congruent sign. Remember, there's our congruent sign, the equal little wavy line on top. Let's put some angles in here. I can say 1, 2, and 3. If I have this isosceles triangle, I know you don't know that yet. But remember we said these two sides of the isosceles were the same last time. So what happens? these two angles are congruent. So that's how we mark congruent angles. We just put a little marking the angle. Is that a formal definition? A little just put the there and you've got it. Angle 1 is congruent to angle 2. They're the same. So we're going to start really marking congruent angles. Fantastic. Moving on. How do you measure these things? So I want you to kind of estimate it, and then we'll actually do it. So when I look at an angle and estimate, I always think about what would make a right angle. What would make 90 degrees? That's 90 degrees. So how much is that? An estimate would be, it looks like around 45 degrees, doesn't it? About half that. So make a good estimate. I don't know. And then actually let's measure. So I'm guessing 45. Let's really measure this bad boy. So when you do this, you have to put the center, that little hole in the protractor on your vertex. That's why it's got these little crosshairs. And then you've got to tilt it so that this line that says 0 degrees actually goes to a side of your angle. So you may actually have to tilt a little bit. So there's the center. It's going to 0. Then I follow it up. It goes 0, 10, 20, 30, 40. Where's it hitting? Well, just past 40. It looks like 1, 2, 3 degrees. So the actual was about 43 degrees. Fantastic. So I've actually got that in there. Pretty cool. Try the next one. Can you estimate it? Let me put this over. And before I estimate it, this one's bigger than 90, so I know I gotta go over 90. Maybe it's 100 degrees. That's my guess. 100 degrees. I don't know. Never measured this before. I just kind of drew it randomly. So put the center there. Gonna line up the 0. Now the 0 is on the left side, so it's like when to use the top, when to use the bottom. You use it when it's 0. This is the sides touching, so it's at 0, so now I'm on top. Here the 0 was on bottom, so I'd use the bottom. So top ones. 10, 20, 30, 40, 50, 60. I went past 90. Oh, I was off. Hey, rough guess. There's the 100. There's 110. Well, not too bad. That's 105, so it looks like what? About 106 degrees. Excellent. And then you may remember these. How do we classify these angles? Well, what's an acute angle? It is angles that are what? That are just adorable. They're acute. They are less than 90. Anything less than 90, technically it's 0 to 90 degrees, is acute. So it looks like this. It's kind of a smaller angle. We know a right angle is what? It is 90 degrees. We know that. And we put that little box, that little right angle box there. That shows that it is 90. When you draw the box, boom, it's 90. If you don't see that, you can't assume that it is 90. And obtuse is really between 90. Let me write that a little better. We're going to say it's between 90. Oh my gosh, what is that? Let's just start from scratch here. It's an angle that is what? Between 90 degrees and 180 degrees. So it's somewhere over there. So it's obtuse. So it's going this way. It's got to be more. Oh my goodness, I'm having issues. How about this? Something like this. So it's something between 90 and 180. So if I look at this first angle up here, it was a cute angle. So cute. And then this one over here was more than 90. It's 106, so I can tell it's obtuse. So you can measure it and tell, or just kind of know it's over between there. So what's a straight angle then? What's left? Less than 90. It is 90. Between 90 and 180, what's a straight angle? Straight angle is 180 degrees. Or, what's that? It's a line. So lines are actually angles. You know, you can put a vertex in here. It's just 180 degrees, so it's a straight angle. Same thing as a line. Very good. Awesome. Moving on. Can we use this diagram to answer the following? So look at this. So we've got multiple marks here. So I'm going to say, oh yeah, this is congruent. See how there's one slash is congruent to the other one slash up here. So these are congruent. Two slashes, or two marks match up, three marks match up. Let's see if we can answer them. Can you find angle CBJ? So CBJ is from C to B to J. So it's referring to this angle right here with the two slashes. Who is he congruent to? He's congruent to the other two slashes. This guy. How do we name him? I can't name him H because there's too many angles. So I'm going to name him GHF or GHD. As long as that H is in the middle, we'll say GHF. How about FJH? Where's FJH? So I go from F to J to H. That's the three-donger here. We've got three of them. And it's going to match up right across the way here. So you can say BJA or AJB. Let's go. What is that angle? AJB. Fantastic. What if we give them actual numbers here? EFD. Where's EFD? EFD is 75 degrees. Then find GAB. Well, they're congruent. They're marked here. EFD and GAB. So what is it? They're the same. That's nice. You know, it's 75. That's 75. How about GHF? Where is GHF at? Oh, we already marked that one. That's 130. It's saying JBC. Where's J to B to C? That's the one it's congruent to. Those are nice. Those are like gimmies. They're the same. So we can say they're equal to each other. Same angle. Very nice. All right. Another definition. Here we go. What is an angle bisector? Well, an angle bisector is a segment, ray, or line that divides an angle into what? It divides it into two congruent angles. Just like a segment bisector divided into two congruent segments, an angle bisector cuts it in half, divides it into two congruent angles. So, can we draw the picture? Saying ray KE is the angle bisector of angle K. So I can draw angle K. Boom. There it is. And what's the angle bisector? It's going to cut it in half, so it's going to come right in the middle here. And I know it's got to have the point E on it, because it's ray KE. It's cut in half, so how I mark it, this side is congruent to that side. So even though mine's not perfect, as soon as I mark it, it is perfect. That means they are the same. They are good to go. So another definition, angle bisector. Fantastic. Moving on. What are we going to do with this? I love it. I love these types of problems. Almost like this proof. I'm giving you information. I want you just to find x. So mark it up here. AT is the angle bisector of MAH. So I mark it right away. Oh, AT cuts it in half? Mark it. They're congruent, man. There they are. Psh, perfect. So then it tells you the measure of MAT is 60. TAH is what? 4x plus 20. Well, if they're congruent, we know they equal each other. So I know these are the same. So right off the bat, you can say, yeah, MAT equals TAH. I'm just going to go straight for it. 60 is equal to 4x plus 20. Why? Because it's bisector, cuts them in half. I know they're the same. Now just solve them. So really it's going back to solving some equations. Let me change colors here. I like to draw the line, keep them separated. Solve for x. What do I got to do? Boom. Subtract 20 from both sides. 40 equals 4x. And then we'll solve for x. What do you got to do? Divide both sides by 4. We're looking at 10. So that's all this one wanted me to do. Sometimes I just want you to find x. X is 10. You can plug it in there. You know this has to equal 60. Double check it. Plug it in right up here. What is 4 times 10? It's 40 plus 20 is 60. So we know we're good to go. Alright, so the first angle was math. Did you notice that? And this is love. Love it. Love math. This time I'm telling you LOV. So find it. L to O to V is this angle is congruent to what? V to O to E. So really OV is the angle bisector. Now, I gave you no numbers here. Just 7x minus 14 and 3x. Let's fill them in. So this is like saying 7x minus 14. The bottom one is 3x plus 12. I know they're congruent, so I'm going to go ahead and set them equal to each other. And it says find x, and I always kind of have to find x first, but then it wants it to actually tell me the measure of the angle. Let's find x. Remember, I got variables on both sides, so I'm going to draw a line. I'm going to bring my x's to the left because there's more over here, so I take the smaller one and move it. So how to get rid of 3x? I subtract it. Whatever you do to one side, do to the other. So I'm looking at 4x is minus 14 equals what's left over here is 12. Solve for x. Got to get rid of this minus 14, so I'll add 14. Add 14. And they cancel out, so I'm left with 4x equals, what is that? 26. This looks like a rough example, Mr. Brust. Divided by 4, divided by 4. I was hoping that would come out friendly. Let's not freak out. Let's do it. 26 divided by 4. You can go to your calculator if you want, but it should be, let's see, 24 goes in there 4 times with 2 left over, 4.5. And now can I use that to figure out the, wait a minute, I'm way off on that. 26, hey, 4 goes in there 6 times. Let's try 6.5. Are you serious? Wow. Alright, so 4 times 6 is 24, and then the half will get me up to 26. So x is 6.5. Just see if you're with me here. So find the measure of LOV. So LOV was what? The measure of LOV, let's change colors here, is, whoa, did I change colors? I feel like I'm making a lot of mistakes in this video. Mr. Kelly's going to yell at me, make me redo it. LOV is really 7x minus 14. So plug it in. Plug in x is 6.5. So really I'm saying 7 times 6.5 minus 14. And again, if you don't know, go calculator. I could take a guess, but I feel like I'm not on a very good streak today. Let me see if I got my calculator. Yes, it's right here, so I'm good to go. So what am I going to do? I'm just going to say 7 times 6.5. Boom. 45.5. Then what am I going to do? Minus that 14 from it. So we've got 45.5 minus 14. So you can go back to your calculator if you want, but really that's just going to be 31.5. So I'm looking at the measure of angle LOV equals 31.5 degrees. Super. Excellent. So first you got to find x, then you can plug it in and find the actual angle. So they're both 31.5. And if you want, double check it. If LOV's that, man, when you put 6.5 in there, you better get 31.5 for this one because they're the same. All right, very good. Moving on. All right, that's the end of the section. That's a quick one there. Yeah, so we know Mr. Kelly's a Bieber fan. We know Sully loves Rebecca Black. I'm not going to lie, I'm a huge Nicki Minaj fan. Obviously, by the picture, you can tell Barbie's Back is my favorite CD. Somebody made this cool test taking tips, set to moment for life. Enjoy. Good luck on the mastery check. Peace out. Keep it real.
Room. Favorite class head nodding to this tune. Knowledge fills up the air like a balloon. I'm so fresh, call me fruit of the loom. Dipped it down in Philly, it's my turn now. Test coming up, feeling so proud. Don't forget the rules, these questions, oh wow. Your strategies work, proficient in the house. In this very moment I'm good. In this very moment I'll say, I know I can, I should. Picking up the pencil, let's start. Cool man like Bart, all you got with all your heart. Two of these answers don't make sense. Yes, this question is hard, so I'll skip. Yes, did I look for keywords in the text? Please, did I read the question properly? Freeze, testing can be tricky. You wanna be picky. Everyone counts, Drake, Alfano, and Nicki. Did I get my sleep? Nutrition is a key. Not being scared and feeling so free. Be confident in you, just saying do you. Formula sheet is your friend, so use it too. Numbers don't make sense, so estimate please. Only color I see is green to me. Does this make sense? I only do dollars. No, we're not talking about the answer, call me blue collar. Test is now done, go back, check your work. Stop being summer, come on, let's do work. I can get this math problem right. Right. Cause in this classroom, man, I feel so alive. I wish that I can get this math problem right. Get it right. Cause in this classroom, man, I feel so alive.